Yeah, like,
he has like half the observations and Sean has the other half.
I wrote down what Sean had.
Today's goals are to learn about the operator interface, how the robot communicates, and the robot system. First, basic electrical theory, Ohm's law, which consists of voltage, current, and resistance. Voltage equals current times resistance. It sounds really
Yeah,
familiar.
this looks a little familiar.
Power, which is measured in watts, is equal to volts times resistance, or times current. This is not stuff you guys will remember, or will memorize. These are sim motors at the top. In the 12-volt system, the current max power. Why do I care about power, resistance, and current? So the robot will use the right fuses, the right wires, be powerful, and won't blow a fuse, and won't catch on fire. Because if you use the wrong size wire with too much power going through it, it's going to catch on fire. Basic types, solid or single stranded wire, or stranded, multiple smaller wires twisted together, or jacketed, multiple insulated wires with an outer cover, which is like Ethernet cable. The size or diameter of a wire is referred to as the gauge of the wire. The smaller the gauge, the larger in diameter the wire. The larger the wire, the lower the resistance per foot. The larger the wire, the more current it can handle. Undersize produces excess heat. So again, if you use too small of a wire for the power you're trying to put through the wire, it'll catch on fire. AWG stands for American Wire Gauge. And this is just a chart that tells you for the power that you're trying to connect, what size wire to use. Typical rules for FIRST robotics for connecting the battery to the power distribution board. Use 6-gauge red and black wire or larger. 12 or larger must be used for all circuits protected by a 40-amp circuit. 14 or larger diameter for a 30-amp circuit. 18 for 20. 20 for the power connection between the power distribution board and the C-RIO. 20 for connection between the power distribution board and the bridge, which the bridge is what communicates to the driver station. Circuit types: power, large power current to drive motors, sensors and actuators, low power signals for sense and control, the digital signal, which connects like the digital signal. It's the Jaguar. You connect that to the digital sidecar, and it sends the signal telling tells the Jaguars when to turn the motors. That's three different wires, and one is a positive, one is a negative, one is a signal. Operator interface. Hardware is the laptop joysticks, and optional is like custom controls. Like either last year or the year before, they gave us the option to use the Xbox Kinect to control our robot, which we did not do. Software is the dashboard. And there's the joysticks. Switches and potentiometers can be used to build custom interfaces or a giant controller. So the components of the robot: power system, a battery and or compressor, actuators, which are the motors, the servos, relays, robot signal light, and the pistons. Sensors are potentiometers, encoders, vision, and gyros. Controllers are the stereo, digital sidecar, speed controller, and lights. And then networking is the router and the bridge. And then when we're wiring the robot, this is a diagram that you can find on the team website that we will constantly be referring back to make sure we accurately wire the robot, because that is something that they go over very closely at the competition, with making sure that you have everything wired correctly. And just more diagrams on how to wire stuff. And this right here is a picture of the power distribution board, which everything that gets power goes through that. Obviously gets power from the battery. The robot brain is the stereo, which are extremely expensive. They're like $1,500.
Well, the smaller one we bought was 700.
Yeah, not cheap. And so if you wire that wrong, imagine just blowing that up. You just lose $700. Compact stereo has 4 slots, less inputs and outputs. Advantage is smaller and lighter, so you can make the area on the robot where you're doing all the wiring a smaller, more confined space.
Is it on a timer for 9
No, I'm just pushing it down, but just going back. So red is positive, black is negative, and white is signal, white or brown. So the digital sidecar, this is what I was talking about, like the 3 wires of PWM cables connect to. And they have to go on there a certain way. When we're wiring the robot, you'll notice that, like, if you plug it in backwards, then it won't work. That's because the signal wire is on one side, so it'll never get sent the signal to turn on and off. LED should always be green when the robot is turned on. There's 10 different outputs, so you can connect it 10 different motors, servos, jaguars. Power connection to the 12-volt output on the power distribution board is there. Then the robot signal light gets wired through the digital sidecar. Must connect. Probably should have looked at this before. Motor speed controls, allow motor controllers, Jaguar motor controllers, you can use those, or we don't use the Victor.
No, but there's a new one called, smaller. No, that's what we got, there's a new motor control that's better than the Jaguar. We got it on last year for the little ones. So this is not dated.
Yeah, this one's a couple of years. So that's what a Jaguar looks like. Those go bad very easily. So on one side of it, you connect the positive and negative for the motor, and the other side the positive and negative for the battery, or from the power distribution board. And another thing is when because how you connect the wire to it is you unscrew the screw, and just screw down the wire. When you're crimping on the connectors onto the wires, you gotta make sure like you crimp it down all the way, and don't try and use the wrong tool. That's a spike. That just sends like a pulse of electricity to turn something on, or turn something one way or another, turn something on or off. Robot signal light, which looks like that. That's a limit switch, so you can have it to where like if something goes up and once it touches that, it won't move anymore. Okay, that's it. That's all the slides. Safety. Yep. So you want me to do the safety with the electrical tools? Are those all in the other?
T-shirt line out, show them the stuff on the t-shirt out, have you show them the slides.